Question 4. Polygons that undergo a rigid transformation do not change in shape or size. Carefully subject each polygon to the indicated transformation to produce an image of the original object. Label point A prime and give its coordinate. For part A, we are asked to reflect shape across the y-axis. So this is my y-axis. When I do reflect, the distance point to its image is always equal. So A, when you mapped to this spot, this will become A prime. So before I even finish drawing the rest of this, I can come down here and I can say A prime is going to be located at 1, comma 2. This point will get mapped to here. This point will be mapped 3 units away from the line of reflection, 1, 3 here. And then I go down and this point. So this is the image after the reflection. A few students decided that A prime was located here, and that would be true if it was a translation where it was just slid over to the right. What is it? 1, 2, 3, 4 units. But this is not slid to the right 4 units. It's reflected across the line. For part B, we're asked to rotate this shape 90 degrees and counterclockwise. I did not specify the center of rotation, and because of that, there's a lot of answers that I accepted as correct. As long as I did see a counterclockwise and 90-degree rotation, and it was clear to me what your center of rotation was. My intent was that you were going to rotate around the origin. So let me put a small dot here at the origin. And one of the ways I like to think about rotations, particularly of 90 degrees or 180 degrees, or any multiple of 90, is to think about the fact that when I rotate 90 degrees, rises and runs switch places, and things that were negative slopes become positive slopes. So if I sketch this line segment, right, you can see that this line segment has this slope pattern where I'm going down 2 units, and then I'm going to the right 1 unit. So it's down 2 over 1, down 2 over 1. Now any line that would be perpendicular, oh, voice is cutting out there. Any line that would be perpendicular to that line would have to have a slope that would be opposite and reciprocal of that. So right now you can see I'm looking at this slope pattern of down -2, -2 over 1. So to be perpendicular, to be a 90-degree rotation from that, it would have to have a slope of up 1 and then to the right 2, so it would be a positive slope. Now I can draw that, and I'll use a slightly different color here, and I'll go in the wrong direction, but I'll just go up 1 and then over 2, 1, 2, right? So this point right here in the origin, those two are specifying a line that would be perpendicular to this. So in other words, what I'm looking at here, let me line this up so it matches. What I'm looking at here is the line that's going to, where this point, if I take this point and I start rotating it around the origin, this point is going to land somewhere on that line. And I can actually see where it's at, because right here you can see this is the same up 1 over 2. So this point is going to live right here. So I know where this point goes. If I was to do the same thing for, I'll mark this one green, this green spot, you can see right now it's down 3 and over 1. Well, instead of that, it's going to be up 1 over 3. This is the spot right here, right? So that would make my 90 degrees with this. Point A right now, it's down 2 over 2. So in order to deal with that, it would be I could go